Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 7, Lesson 6, but before we get started, I want you to take a look at numbers 1 through 5 and make a prediction for the value of x in each of them. So pause the video, write down your guesses. You're just guessing. Some of them you might know, some of them you might guess, but write down what you think those values would be, and then at the end of the lesson, I'll show you what they are, and you can see if you got them right. So our goal for today for 7.6 is we're going to find the measures of angles formed by lines intersecting on the circle, inside a circle, or outside of a circle, and how they're different, how you have to calculate them differently. So as a quick reminder, in section 7.5 we learned about what a tangent was, and remember a tangent is a line that intersects a circle in exactly one point. So in this top picture right here, line AB is a tangent. It intersects the circle at point A, the point of tangency. Well, today we're also going to learn about a thing called a secant. And a secant is a line that intersects a circle in exactly 2 points. And so, for instance, look at line J. Line J intersects circle C here and here. It intersects the circle in 2 points. So J is a secant. K intersects the circle in 2 points. So please jot down the definition of a secant, a line that intersects the circle in exactly 2 points. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. That sounds pretty confusing, and so let's just go through kind of an example, and hopefully that will help. Let's say we want to find x. We want to figure out how big this angle is. Well, to find that, we need to know, I'll call this y out here for the length of this arc, and I'll call this z out here for the length of that arc. And so to find x is going to equal y plus z divided by 2. You add the arc measures and divide by 2. I want to point out something else. This point where the two secants intersect is not the center of the circle. Remember, if your angle stems from the center of the circle, let's say this is 75 degrees, then this arc is just 75 degrees. That's a central angle, and remember, they're the same measure, the arc and the angle. That is not the case when the point is not at the center of the circle. Here's an example. Number 1, we want to find the value of x. You can see this point V is not the center of the circle. So to figure out how big this angle is, it is not just 130. We have to add the arcs. So to get x, we're going to add 84 plus 130 and divide by 2. We add this intercepted arc and this intercepted arc and divide by 2. According to my calculations, we get 214 divided by 2, which is 107 degrees. So that is the measure of the angle. Let's try number 2. So for x, it's not exactly in the same spot as before. What if I put a y right there? Could I find the measure of y? The answer is yes. I could add these two arcs and divide by 2 to get y. And then once I know y, remember here we have a linear pair and they add up to 180. So we're going to start by finding y. Y is going to equal 75 plus 143 divided by 2. So let me type that in here quick. 75 plus 143 equals, and then divide by 2. I get 109. So y equals 109 degrees, but y and x together should add up to 180. So to get x, we're going to do 180 minus 109, which is 71 degrees. Then we have a third situation. Number 3, they actually do give us the angle, but they don't give us one of the arcs. And so can we work backwards? Can we somehow find how big arc GH is? So what we do is we think about our formula. Usually it's the angle, so the 110, is equal to the two arcs added together, so x plus 97, and then divide by 2. So remember, you add the arcs and divide by 2, and that equals the angle. So that's how we set it up. Think about how you get x by itself. I'm going to start by multiplying by 2 on both sides to get that 2 off the bottom of the fraction. I wind up with 210 on the left and x plus 97 on the right. Minus out 97. And 123 equals x. And that will be degrees because it's the measure of the arc. You could go back and check your answer. If we think about adding 97 and 123 and dividing by 2, we should get 110. Please pause the video and try number 4. So here we are looking for arc JK. We're trying to solve for x. We already know the angle. So remember, usually it's the angle equals one arc plus the other arc divided by 2. So our arcs are the x and the 25. So we add those together and divide by 2, and it should equal 60. To solve this, we're going to multiply by 2. Whatever you do on one side, do on the other side of the equal sign. We wind up with 120 equals x plus 25. Subtract your 25. And we have 95 equals x. And again, it will be degrees because it's an arc measure. So the first 4 problems were all examples where we had 2 secants or 2 chords and they crossed inside of a circle but not at the center of the circle. Now we're going to talk about what happens when they cross right on the circle. So if a secant and a tangent intersect at the point of tangency, like point A, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So for instance, the measure of angle 1 will be however big arc AB is, so the measure of arc AB divided by 2. So if arc AB is 100, then angle 1 is 50, for instance. And we can say the same type of thing for angle 2. The measure of angle 2 is going to be the measure of arc ACB divided by 2. So if arc ACB is 260, then angle 2 would be half of that, or 130. Let's try some examples. Number 5, let's find the measure of angle QPR. Well, if we trace from Q to P to R, we are talking about this angle right in here. Notice how it opens up to the 148-degree arc. So to find the measure of angle QPR, we're just going to take 148 and divide by 2. And that ends up being 74 degrees. So this angle would be 74. So when your two things cross and they are right on the circle, like angle P is right on the edge of the circle, you just divide the arc by half. Let's try number 6. Number 6 is a little strange. They want us to find the measure of arc DEF. Now DEF is way out here. DEF, that's the arc they want us to find. But remember how a circle is 360 degrees? I'm thinking if we could find arc DF, this red one that I'm just outlining, if we could find that and just subtract from 360, we should get arc DEF. So remember this angle right here is 64. The arc that it opens up to should be twice as big. So to find the measure of arc FD, you're going to take 64 times 2. Which is 128. So this arc out here is 128. What we really want is the blue arc, arc DEF. So to find the measure of arc DEF, we're going to take 360 minus that 128, because a whole circle is 360. Is 122, which means this part of the circle, arc QS, I guess I could label that the measure of arc QS, that's 122. So if I want the measure of angle RQS, which opens up to that 122, I just cut it in half, because this point Q is right on the circle. So 122 divided by 2 ends up being 61 degrees. So this angle would be 61. And here's our third scenario. What if you have two secants or two tangents or a combination where they cross outside of the circle? Remember, our first situation was we had two things and they crossed and it was inside the circle. The second situation was we had two things and they crossed right on the circle. Now we have two things, and where they cross, it's outside of the circle, like these three pictures up above. So when that happens, I'm just going to erase my mess down here. When that happens, you subtract the two arcs and divide by 2. So let's write this out. For all of these pictures, if you wanted to find the measure of angle A, what you're going to do is take the big arc, so the measure of arc DE, and you're going to minus the smaller arc, so the measure of arc BC. And then you're going to divide by 2. So let me show you one more time. You take this red arc minus this blue arc and divide by 2. Same thing here. Red arc minus blue arc, divide by 2. And that gives you this angle outside of the circle. This angle outside of the circle. Let's try a couple. Number 8, find the measure of angle L. So we're trying to figure out how big is this angle. Notice that angle is outside of the circle. So think about your two arcs. One arc is really big. It's right here, arc HJK. And then the other arc is the 102 in here. So when your two chords or secants meet outside of the circle, like they do, L right here is outside of the circle, you take big arc minus little arc and divide by 2. So that's what we're going to do. We need the big arc though. So remember how a whole circle is 360? 360 minus 102 is 258. So this big arc here around the red part, or HJK, is 258. So to get the measure of angle L, you're going to take 258 minus 102 and divide by 2. And I got 78 degrees. Number 9. This time they gave us the angle and they want us to find the arc from C to D. So think about the process. Usually it's the angle equals the big arc, I'll call that X, minus the little arc, which in this case is 95, and divide by 2. So let's say that again. The angle equals the big arc minus the little arc divided by 2. Why is it minus? Because this angle, 56, is outside of the circle. Multiply both sides by 2. You get 112 equals x minus 95. Add 95. And we get 207 equals x. And that's going to be degrees, because it's the measure of this arc out here. And you could check it, do 207 minus 95, divide by 2, and see if you get 56. You should. Please pause the video, try number 10. So since angle S is outside of the circle, we're going to do big arc minus little arc, divide by 2. So 179 minus 71, divide by 2. And I think we get 54. So the measure of angle S should be 54 degrees. Last problem. The diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If the measure of arc AC is 128, let's label that. This arc out here is 128 degrees. And the measure of arc XBY, so that's this arc from X to B to Y, that is 84 degrees. What is the measure of angle D right here? So remember, the angle D is outside of the circle. So we're going to have to subtract the two arcs. So we take bigger arc minus little arc, divide by 2. And this should equal the measure of angle D. And I think we get 44 divided by 2, which is 22 degrees. Let's go back to your predictions from the beginning of the notes. So check out your predictions. Did you get these answers correct? This is a central angle. It's right at the center of the circle. It should be the same. So this one is 100 degrees. Central angles and arcs are congruent. This is an inscribed angle. This is from section 7.4, I believe. And if it's right on the circle, it's half of the arc. So we should take 100 divided by 2. This angle ends up being 50 degrees. Next, X right here. These secants cross inside the circle, or those chords, I guess they're chords. So what we do when they cross inside the circle but not at the center is we add the arcs and divide by 2. So we're going to add the 50 and the 100 and divide by 2. You get 150 divided by 2, which is 75 degrees. Here, number 4. This angle is right on the circle. So again, we just take half of the arc. So this one's just 100 divided by 2. You should get 50 for this angle right in here. And last but not least, here angle X is outside of the circle. And when they're outside of the circle, you subtract the two arcs and divide by 2. So subtract big arc minus little arc, you get 50 over 2, which is 25. Did anybody get 5 out of 5? If so, good work. That wraps up Unit 7, Lesson 6, so try the practice, and if you have questions, let me know. Have a good one.